Why does the sky appear blue? Will the sky be clear in Bengaluru tonight? Which Indian destination would be best for a family astronomy trip this December, considering cloud cover, light pollution, travel cost, and accessibility? This diagram shows how an AI processes those three prompts. It instantly splits into three entirely different internal mechanisms. One takes a fast, direct path. Another scans outward for specific targets. The third splinters into a massive, multi-branched investigation. But all three of these questions are about the exact same topic, the sky. So why should an AI handle them so differently? Because the topic does not decide the mode, the task does. Explaining a concept triggers normal AI. Finding local weather requires web search. Planning a complex trip initiates deep research. And if that trip involved a high-stakes health or legal decision, you would need to verify your findings with a human expert. Knowing how to pick the right tool saves you time, computational power, and frustration. The rule is simple. Use the lightest AI mode that can answer your question reliably. Normal AI is a direct, closed-loop process. You provide a prompt and context. The model understands the task, it reasons through it, and it generates a response. If you ask it to rewrite an email to sound professional or summarize a document you've pasted into the chat, it executes the task immediately. It can do this quickly because it is not performing a live internet search. It relies entirely on its pre-trained general knowledge and whatever context you directly supply in your conversation. Because it draws on learned patterns, a highly confident response from normal AI can still be incomplete, outdated, or wrong. If your task involves explaining, summarizing, rewriting, or creating, and you've already supplied the necessary facts, normal AI is usually all you need. Let's test that. If I say, rewrite my resume summary, normal AI can handle it. But if I pause and add, check whether this resume advice matches the current hiring market, the process changes instantly. The topic stayed the same, the evidence requirement changed. Because we asked for current conditions, the interface recognizes that fresh external information is needed, abandoning internal reasoning to activate web search. This flowchart shows how web search operates as focused retrieval. If we ask for the current application deadline for Sunrise Institute's 2026 engineering program, the AI interprets the question, forms focused search queries, and scans external results. It filters out web pages that are outdated, promotional, or unofficial reposts. It inspects the remaining evidence for source authority and date, throwing away what doesn't answer the question. Web search doesn't read the entire internet. It is an efficient tool built specifically to locate, check, and update facts that change, or to find location-specific and official information. But you have to match the tool to the task. If I type, rewrite this birthday invitation, and accidentally trigger deep research, the AI might start analyzing the cultural history of invitations and generating cited reports. That's a waste of time. Normal AI was enough. More research is not always more useful. Now, consider a different prompt. Which city may best suit an experienced Indian software professional relocating with a spouse and a school-aged child? Dubai, Singapore, or Berlin? A single web search will fail here. There are too many variables. This diagram illustrates the 6 phases of deep research. First, it clarifies the goal, identifying missing constraints like the housing budget or visa length. Then, it builds a research plan, splitting the question into major branches, like visas, taxes, housing, and schools. In phases 3 and 4, it executes multiple search paths simultaneously across government portals, industry reports, and official statistics. It evaluates every source card for credibility and recency, discarding promotional or unverified claims. Phase 5 is where true research happens. The system finds an unresolved gap. Schooling costs are not yet comparable between the 3 cities, so it iterates. It launches a fresh, targeted search purely to fill that specific gap. Finally, it synthesizes the evidence into a report, detailing assumptions, trade-offs, and uncertainties. Good research rarely reveals one magical answer. It shows which option fits each of your priorities. But if I ask, what time does tomorrow's train leave? And the AI begins a multi-branch historical investigation of the railway system, I'm stopping it immediately. One focused web search was enough. Deep research demands more time, more tool usage, and more effort from you to verify its long reports. Do not choose the most powerful-looking mode. Choose the lightest mode that can answer reliably. Selecting the correct mode in your AI interface is only half the job. Your prompt must actually match the task you're assigning. A standard prompt relies on a goal, context, and desired output format. But to properly steer deep research, you have to extend your prompt. You must explicitly state the scope of your investigation, your specific evaluation criteria, and your source priorities, like government or technical sources. A vague deep research prompt will just produce a long, poorly targeted report. Let's test your intuition. Turn these notes into a professional email. Normal AI. What is the current price of the laptop model I selected? Web search. Which laptop under 80,000 rupees best suits 4 years of engineering, coding, and beginner machine learning work? Deep research. Summarize the PDF I uploaded. Normal AI, using supplied content. How about check whether all statistics in this PDF are still current? If it's just a few focused claims, web search. If many connected claims require broad investigation, it scales up to deep research. Boundaries are determined by scope, not rigid labels. The constraints and specific instructions you write into your prompt act as the definitive steering wheel for whichever engine you choose. This flowchart shows our final decision path. Can the task be completed from supplied context or stable general knowledge? Normal AI. Does it require current, externally verifiable information? Web search. Does it involve multiple sub-questions and trade-offs? Deep research. And is it a consequential health, legal, or financial decision? Verify important findings with an appropriate human expert. Let's give my younger brother, Deepu, a test. Deepu, explain what a solar panel does. Normal AI. Good. Now find the current solar subsidy in our state. Web search. Exactly. Finally, should our family install solar panels based on our roof, electricity use, installation cost, current subsidy, maintenance, and long-term savings? Deep research, followed by verification of the important assumptions. Think of one question you recently asked AI. Did it need an answer, a search, or real research? Share your example in the comments. Remember, ask clearly, search when needed, research when justified, and always verify what matters.